Okay, another vocab that we need to talk about are arcs. Okay, arcs are any part of the circumference. So there's three different types of arcs. One is a major arc, one is a minor arc, and the other is a semicircular arc. Okay, so a major arc is an arc that's greater than 180 degrees, and we use three letters to notate this arc. If we look at the figure below, we can say that because we have this central angle here of AOH, we can either go from A directly to H if we want to know what this arc length is, or we can go all the way around and get the arc length of the major arc. Okay, so every single central angle here has both a minor arc and a major arc, but we have to know which one we're looking for. So a major arc is an arc that's greater than 180 degrees, and we use three letters to notate this. And a minor arc is an arc that's less than 180 degrees, and we will use two letters to notate this, the beginning and the end. And then a semicircular arc is an arc that is exactly 180 degrees. And you can use either two or three letters to notate. Okay, so if we look at this angle down here, angle AOH, we know this is a central angle because O is our center of the circle. Okay, so if we want to know what this arc length is here from A to H, this would be called a minor arc. So we're just going to use two letters to notate this. And the two letters that we're going to use are the beginning and the end of this arc. So this arc right here would be notated using the letters A, H, the 2 points, and then an arc above it. Okay. Now, if we wanted to know what the major arc is that's associated with this, we're going to start at A and we're going to go all the way around the circle until we get to H. Now, without having a different notation, you're not going to know what arc you're looking for. Okay, so in this particular case, we're looking for the major arc. So again, we start with the letter A. We're going to pick a different color for this one. We start with the letter A, and we're ending with the letter H, but we're going all the way around, so you can pick any of these other points that you go through in order to notate the major arc. So this arc here could be arc ABH because we're starting at A, we're going through B before we get to H. You could say it's ACH, arc ACH. You could say it's arc ADH. We could say it's arc AEH. You could say it's arc AFH. You could say it's arc AGH. All of these indicate the exact same arc. The arc that goes from A to H, and it extends through one of these other points. It's the major arc of angle AOH. Okay, so this is the major arc, and this would be the minor arc. Okay, now what if you had another letter in here, like say T, but we still want the minor arc between the minor arc of central angle AOH? You would still just use the two letters, the beginning and the end. It doesn't matter that you extend through another point. You just want the beginning and the end because it's a minor arc. Okay, so this is the beginning point and this is the end point. Now, could you go the other way and say it's HA? Yes, it doesn't matter which way we go. Okay, so I typically go in that counterclockwise direction, but you don't have to. Okay, now a semicircular arc is an arc where there's an exact 180 degree measure. Okay, so you can use either two letters or three letters to notate this. The reason it doesn't matter is because the arc is exactly the same no matter which way you go, because it's exactly 180 degrees. And so if we want to get, we know this angle here, this central angle here is 180 degrees. which means that this arc up here is 180 and this arc down here is 180. Okay, so you can go either from B directly to A this way, and you go 180 degrees. Or if we go from B to A this way, you're still going the same distance of 180 degrees. So this semicircular arc, it doesn't matter which way you go, because in either direction it's 180 degrees. Now, arc length. The arc length is a distance of a specific part of the circumference of a circle. Now, we've already talked about circumference, and we did this in class, and if you weren't here, I'll go through another example. But the arc length is found by determining what portion of the circumference you need. Okay, so it's a specific part. And now, when we're talking about part here, we want to know in relation to the entire circle. The entire circle is 360 degrees. So we want to know what angle measure. So the angle measure of the arc divided by 360 degrees times the circumference of a circle. Because remember, in math, when you see of, that means multiply. Okay, so the circumference again is 2 pi r. So we've got the angle divided by 360 times 2 pi r to determine what the arc length is. Okay, so if we have this circle here that has a radius of 5 centimeters, we can find the circumference by saying circumference is equal to 2 pi r, where r is 5 centimeters, so I substituted this in. Okay, and if we multiply, we have 2 times 5 is 10, and we're just going to bring down that pi, so 10 pi centimeters. Now this is the exact answer in terms of pi, and it's in terms of pi because we didn't use a value to represent pi here. We didn't use 3.14, or we didn't put pi in our calculator to get an answer. We just left it in terms of pi. This is the most exact answer you can have, okay, when it's in terms of pi. And we want to make sure that you include units because we're talking about a distance. Sorry, my dog is barking. But if we want to know what this part of the circle is, the part right here, this part of the circle, we need to know what angle this is here, or what measure this part is up here, what measure of the arc it is. Okay, well, it happens that if you have a central angle, that this angle is going to be 120 degrees if the arc is 120 degrees. And that works if you have a central angle, but we haven't actually talked about that yet. Okay, so your first step is going to be, what ratio of the circle are you looking for? Well, we know that this arc here is 120 degrees. And so you're going to put the 120 degrees over the whole, which is 360, and divide. Okay, so this is going to be 120 divided by 360, which is 1/3 of the circumference of the circle. So then you would say, what is 1/3 of 10 pi centimeters? Because remember, when you have a circle that has a radius of 5 centimeters, your circumference is 10 pi centimeters. So we want to know what is 1/3 of 10 pi centimeters, and that would be 10/3 pi centimeters. And you can leave it just like this, or if the book says, or if your directions say to leave it in terms of pi, this is the answer you're looking for. And if the directions do not say that, and it says use your calculator's value of pi, then you would substitute. You would push that pi button on your calculator to get your answer, and then round accordingly. The majority of time you're going to be rounding to the nearest tenth, which is your first decimal place. Okay, but let's look at one of your problems in your book. Off the top of my head, I don't remember which problem this is, but it's one that you will be assigned to do in class. So if we have a problem like this, the measure of arc IJ is 80 degrees and the diameter is 10 centimeters. What is the arc length of ij. Now, we don't have a picture given to us, so if you need to see a picture, draw one, okay? So just draw it. Doesn't have to be exact, it just needs to be something that's going to allow you to do this problem. Okay, so I'm going to call this point right here my center. Okay, and I want to know the measure of I. I know the measure of ij is 80 degrees. So I'm just going to pick 2 points here. I'm going to call this I. I'm going to call this J, and I'm going to indicate my arc right here, and I'm going to say that this is 80 degrees. Okay, I know my diameter is 10 centimeters, so I'm going to write that in as well. 10 centimeters. We're going to go this way. I know this entire length is 10 centimeters, and I want to know what is the arc length of ij. Okay, well, I need to recall when we're talking about arc length, we know it's a part of the circumference, so let's find that circumference. Now, my circumference has the equation of 2 pi r, and what's given to me is the diameter. I know the diameter is 10 centimeters, so I need to convert my diameter into a radii. So my radius is going to be half the diameter. Remember, the equation for radius is diameter divided by 2. So that's going to be 10 centimeters divided by 2, which is 5 centimeters. So I have my circumference is equal to 2 times pi times 5 centimeters. 2 times 5 is 10 pi centimeters, and this happens to be exactly the same as the problem I just did. So my circumference is equal to this. Now I need to determine what part of my circle is 80 degrees. So I'm going to say 80 divided by 360. These are going to cancel. So I have 8 over 36. And I don't have a calculator on me, so we're going to do this. I'm going to divide by 4 and divide by 4. So 2/9. So I know I'm looking for what is 2/9 of 10 pi centimeters. So my arc length is 2/9 of 10 pi centimeters. The 2/9 came from the part of the circle. What part of the circle? And the 10 pi came from the circumference. Okay, so if I do the math here, I know that I can say 2/9 times 10 pi centimeters, put this over 1, is going to be 20 2 times 10 is 20, so 20 pi over 9 centimeters. And this would be my exact answer. I could, if the question's asking you to leave it in terms of pi, just leave it just like this. Okay. Now, because we're looking for just an arc length, a length is a distance, so you need to include your units. Your units are going to be measures of lengths, so centimeters, meters, miles, feet, kilometers, anything that's a unit of length measurement. Okay.